Okay, so good evening. Fine. So let us start the session. Hope the presentation slide is visible and my voice is audible. Yeah. Okay. Okay. Fine. Good. Okay. Thank you. Thanks for the response. Okay. So let's start. Let's have no a discussion about business analytics. We know what analytics means, right? Analytics is all about the calculation. Okay. So you have a data in hand. You have some information in hand and you have the numbers or figures. So it could be a raw information or it could be a processed information. If it is a raw information or a raw data, you're going to know like do some calculations, know like to predict something, or to know uh, what has happened in that process. Okay, so that process has already been recorded. That's why we call it as a data or information. It's a like historical data. Okay, so an event has happened, an event has occurred, and that event has been transformed into information. And when we feed that information into the system, it becomes a data. Okay, so when the information is fed into the system, that becomes data, and using those data whether it is in the raw form or it is in the processed form, whatever. So when we use those data, further we know like analyze it, calculate it, like, and we do some like workout on that, and we come to a conclusion. So that conclusion maybe give you the idea about what actually has happened in the past, why it has happened, and where was the root cause of the problem. If something bad has happened, that is like if something, the company has faced any loss, why it has happened, what was the root cause of the problem. And to predict the future as well. That there's no like for in the future how the company will like progress, and how the expansion of the company would be, how many more customers will like come into the company. I mean, no, into the organization. That is no like buy more products from the organization. So, or no, how many markets the company can like organization can expand. Like it can expand like after some time. So all this calculations, all this pre-assumptions, all this forecast, and like speculations, everything like is got by calculating, by like doing some multiple calculations, by doing some like analytical calculations based on the data. So that is called business analytics. So why business analytics is done, why we have to do an analytics about the business? To expand the business, to know the prosperity of the business, either to know the present condition of the business, you do a business analytics, or you want to know what has actually happened in the past, you do business analytics. Or if you want to know like predict your organizational future, you do business analytics. Or if you want a solution to a problem, the problem is already existing, you need a solution, and you want to see after implementing the solution what the result will be, you have to do a business analytics. So now business analytics, no, it's been in a broader sense, like it is almost like omnipresent in many organizations. No, all over the world, they are not doing business analytics. So anytime it can be done. It doesn't mean it's not like a balance sheet which has to be like published once in a year, at the completion of the accounting year. It's not like this. Business analytics is done anytime, like whenever the management, top management wants to understand something, whether it's about the past of the organization, the present of the organization, or about the future of the organization. So whenever they want the result, or whenever they want to know what has happened or what is going to happen, they can conduct business analytics. So which is the team, who are the persons who conducts this analytics? There are analysts who are like who knows very well about the this analytical techniques like big data or power bi, whatever it is. There are like technicians available, and that will be a team. Like if the organization is big enough, or if the data is like big enough, There will be a team of like individuals, experts, no, working on this analytics part. So they will be called as no like analyst, business analyst. Okay. Okay, so let's start. Okay, so why it is done, to define what is analytics. That is what we are going to see in this subject is actually what analytics means, and to understand the evolution of the business analytics, how it all started. Everything has a starting point, right? So how it all started, when does it actually started? And to understand the data analytics methodology, there are various methodology, to do the analytics part. So to understand its methodology, how it is done, and to discuss the different roles of analytics in various industries, to identify the challenges and opportunities of analytics in different sectors. So let's see what actually business analytics means. It is a process by which company use data either created by their operations or a publicly available data. So publicly available data. So where you can find the data publicly, that is where it is available in the public. You can now search for printed journals, printed business magazines, and digital printed journals and magazines. You can find the get the data, like from the publishings. Many scholars would have like done various research about this thing. So in this area, so you can get it from the publishings, or you can get the expert opinions. There will be many experts in the market, right? In the industry, so you can get their expert opinion from them. So these are the data which is publicly available. Okay, so either the company can take it from their own organization, from their past operations or the present operations, or they can like go publicly to collect the data. So why? To solve the business problems, monitor their business fundamentals, identify new opportunities for growth, and better serve their customers. And it is a type of analytics that helps organizations to mine, that is, to retrieve. Okay, so from the, from the core point, to retrieve it, to mine, process, to the calculation, and visualize important business data and take advantage of patterns in their businesses that they would not see otherwise. And it involves either individual pieces of data or data sets. It depends on the event which has occurred. Okay. So if it is a set of events, interconnected events, you will have the data sets. Or if it is just a single event, you will have just a piece of data. So data or data sets which are either stored on premise or in the cloud. Cloud means like here cloud refers to the technology. There is the cloud based input system. That is the what do you say, the secure system. Data sets that increase beyond a certain threshold are commonly referred to as big data, because like if there are like 10 million data available, it is very difficult for any machine to process it and get the results. It will take like even the machine calculates it. It will take like massive amount of time to get the final results, and sometimes the machine may crash. Okay, so dealing with like such an enormous data is like impossible. That's why uh, the technology which can like deal with such a big tremendous like data, that enormous data, so that is called as big data. Okay, so data sets that increase beyond a certain threshold are commonly referred to as big data, which requires significant computational power to access and analyze. And this analytics uses data exploration, data visualization, integrated dashboards, and more, and to allow users access to usable data and insights. So not only for calculation, not only for analysis purpose, you can input the data, you can retrieve the data anytime, like from anywhere in the world. If those persons or the organizations are interconnected with each other, so they can retrieve the data anywhere from the world, and they can process on it as well. Okay, so there are four types of analytics. First one is descriptive analytics. If an organization wants to know what has happened in the past, okay, so some event has occurred, so they couldn't believe it has happened, and like unexpectedly it has happened. They weren't prepared for that, and that their calculations have somehow missed out, and they didn't want to continue with the same pattern, or they want to avoid those mistakes in the future. So for these reasons, to know exactly know where the wrong has happened, where the error has occurred, no, so to what happened in the past, so descriptive analytics is done. So this type of analytics, it helps organizations understand what has happened in the past. It involves analyzing historical data to identify the trends, patterns, and relationships. So two sets of events might have occurred. There will be there might have two different events, or related to each other. So when doing descriptive analytics, it clearly shows the relationships between these two events. So it can be a cause and an effect. Okay. So something has occurred, and no, the effect has occurred after some time. So two different events, or two events, interconnected with each other. Descriptive analytics is used for monitoring business performance and identifying areas for improvement. So here know what has happened in the past. So where it has went wrong, where it went wrong, and what is the relationship. So if the cause has been eliminated, so the effect will not happen, right? So you know the pattern very well. So to understand the pattern which has already happened, businesses know they do descriptive analytics. Then comes the diagnostic analytics. So this is done to identify the root cause of a problem. So in descriptive analysis, you're now having an idea about when it happened, why it happened, and how it is related to other events and everything. But in diagnostic analysis, you have to know, you can identify, get into the root cause of the problem or root cause of the opportunity. So this type of analytics, it helps organizations understand why something has happened in the past, and it involves analyzing data to identify the root cause of the problem or an opportunity. Diagnostic analysis is useful for identifying the factors that contribute to business performance. So the third one is predictive analysis. So we know very well what the term means. Predictive means you're going to predict the future event. So you're going to, assume, you're going to forecast the future events. So this type of analytics, it helps the organizations understand what is likely to happen in the future. It involves analyzing data to identify the patterns, relationships that can be used to make predictions. And predictive analytics is useful for forecasting the business performance and identifying opportunities for growth. Now, when it comes to forecasting, there are various forecasting techniques. As you know, there are no qualitative techniques, and no there are quantitative techniques. And if you have no data, imagine a company, the new startup, right? So it's a new startup or a newly set up company, an organization. So obviously it won't be having the past data in hand because this is a new setup. So only hereafter they are going to launch their product or service in the market. Okay. So obviously there won't be any past data based on their previous operations. Okay. So in that case, so where there is no data available, the companies can go for qualitative analysis, qualitative predictive analysis, qualitative forecasting analysis. And how it is, there are various ways to do the qualitative analysis. One way may be, giving the questionnaire, giving the feedback form to the customers or a set of consumers in the market, asking them to give feedback about it, about the product which the company is going to launch, or about the service. Okay, so based on those consumers feedback, the organization, they go with the right procurement method, the right kind of raw materials, and then produce, and then they sell it in the market. So this is one type of qualitative predictive analysis. And another way to go with qualitative analysis is the Delphi method, which is a very oldest technique. So experts in the organization, they come together, and they give their opinion on the future, the future demand, which is going to happen in the market, and how much the company has to be prepared for it to meet the demand. okay, to satisfy the demand of the customers. So how much the company has to produce, okay. So these experts, they give their own opinion, and all the opinions are collected, and whichever opinion gets the maximum vote, okay. So that opinion is no like taken into consideration, and that would be no like executed, okay. So that is no expert opinion poll method, the Delphi method, or expert opinion poll method. And one more way to go with qualitative predictive analysis is few companies, no, like they give out sample product, no, to do a test in the market. So they produce a limited number of sample products. It's not the actual product, okay? That's not the final product. So they will give a sample product, okay, and like a protocol of the product or the service. So they select a group of, or no, like a group of consumers in the market, or they select a group of markets, and they know like distribute the sample products no free of cost, okay. So after using the product or after utilizing the service, the consumers will give feedback about the product or the service. So based on their feedback, so they will this organization will do some enhancement on the existing that prototype, okay, that prototype product. So they will know like enhance the product, whatever the customer has asked for. If it is feasible for the organization, they will go with it. Then they know they will go with launching the product in the market. So these are the various ways, no, to go for qualitative predictive analysis. That is qualitative forecasting analysis. So this is done only when the data is not available. That is, the historical data is not available. Okay. Because this is the first time the company is launching the product or launching their business. So since past operations is not available. Another thing is no like the company could be an existing company. They are not new to the market. The company could be like already existing in the market. They would be already existing, but they are going to launch a new product which is completely different from their other product. So in this scenario also, no, there is no past data available, because this is going to be completely a new product, not just like the other products, no, what they have already done, no, given in the market. So in this case also, no, there is no past data available. With regard to that new product, there is no past data available. So in this case also, they can go with the qualitative predictive analysis. Yeah. And then quantitative predictive analysis. Quantitative is you need to have the data. If you want to go with quantitative analysis, predictive analysis, forecasting analysis, you need to have the data in hand. That is the past data, the historical data in hand. So there are many methods, no techniques to go with quantitative analytics. You have this time series methods, and you have this causal methods. That is cause and effect. That is, if the price of or the demand of one product increases, its a related product, the demand for its related product, it also increases. So the demand also increases. For example, if cost of the milk increases, obviously its byproducts like curd, what do you say, like paneer and cheese. So that also increases, right? Because they are related products. It's a byproduct, right? So that is causal method. So a cause has occurred, and because of that, like some effect has happened in the market. Cause and effect. That is causal method. So that is that is one way of going with quantitative analysis or predictive analysis. And another way is the time series method. Time series method is it is very simple. Either the company takes the latest sales analysis, that is latest sales result, what has happened the previous day, how much sales has happened the previous day, or how much sales has happened like the previous week or the previous month. Okay, so this is a latest time period method. So whatever sales, how much ever sales has happened in the last week, the same sale will happen this week as well. And whatever sale is happening this week, the same sale, the same demand will continue for the next week also. This is the latest time series method. And you have the simple average time series method, simple average. So here the organization takes the average sales which has happened in the last quarter. Last quarter in the sense, say, like you want to predict how much your business will do, okay, for this month. That is by the end of the January 2026, by the end of January, your organization wants to know how much they can perform in the market. That is how much profit they can make, or how much products they can sell, or how much service they can give. Okay. So in that case, they can take for the last 3 months data. So how much has happened in the month of October, November, and December 2025. They have to take the number of sales has happened, or number of best services has been given. So you have to take the average of all the 3 months, the sales of all the 3 months, and that average would be the sales happening for the month of January. That is a simple moving average method for doing a quantitative analysis. And one more is there, weighted moving average. Weighted moving average is another simple concept. So in weighted moving average, any period or any season where the sale has happened because of an event, or because of some trend has happened in the market. There was a sudden trend, and because of that, the demand for the product has increased, and the company has supplied more than it actually has to supply. Okay, so those time, those days, or those weeks, or those months, where the sale has hiked because of new trend has happened, or because of some any occasion, special occasion has arrived, so that month will be taken out from the calculations. So for example, last month December was it was a season, right? It was not like it was a Christmas season. So Christmas happened, then New Year happened, so obviously people would buy more, right? Obviously everywhere the sales would have hike. So that particular the December month will be omitted. That will be taken out from the calculation. So the previous month will be added to the calculation. That is, instead of October, November, December, you will be taking September, October, and November, omitting December. So whatever sales has happened in the month of September, October, November, so those sales average would be calculated, and that average would be the actual sales which will be happening in the month of January. So this is how the businesses do some predictions, okay, based on the data available or not available. So if the data is not available, they go for qualitative analysis. If data is available, they go for quantitative analysis. Both has its pros and cons. Both the predictions, the techniques, it has its pros and cons. If the company wants to take quick decisions, make use of the nearing season, they immediately want to go for procurement, production, distribution, and sale of the product, so that though they can make the maximum profit within a short span of time. So for taking short-term decisions on sales, marketing, and advertising and everything, you can better go for qualitative data. So you don't have to go for quality. Even if you have data available, you don't have to go for quantitative technique. Okay, so you can better go for qualitative technique, because it's for very short span of time. So easily through expert opinion, through market research, and by giving out the sample product, you can easily get the pulse of the customer, and you can go with the products or the service. But if you want to know um, what go with the strategical decision, that is for the long term plan. If your organization is looking for a long term strategy or a plan, then they have to go for the quantitative analysis, that is based on the historical data. Clear? So this is how it is done. So finally, prescriptive analytics. So why companies do prescriptive analysis? So to understand what actions they have to take in the future to achieve a desired outcome. So predictive analysis is done to understand what is likely to happen in the future, how much sales would happen. But prescriptive analysis is done what has to be done to make the sales happen. So this type of analytics, it helps organizations understand what actions to take to achieve a desired outcome. It involves analyzing data to identify the best course of action to take in a given situation. Prescriptive analytics is useful for optimizing business processes and improving the decision making. Okay. So when did analytics start started? So if you know, like see the businesses know, like in the earlier in the years, in the sense, no, like before all this industrialization, all this, no, like happened, no, like it was just a concept because no machineries were not invented, mass production was not, no, like what was not happening in those days because there was no machineries, there was no like industry, so there was no mass production. So every product was a customized product, handmade, customized product. Okay, so it all happened no in the late 1700s. So it was a rise of the statistics and no like all those calculations. Then came no this Turing machine. It's the earlier invention of the computer machine, the Turing machine, no, for calculation. And after 1900s, no, like this machine learning, no, like that gradually, no, like it happened. And in the early 2000s, scientists, the computer scientists, no, like they started working on the neural networks. That is, no, like um, taking the calculations for no from the smallest number to the biggest number, from the smallest data to the biggest data. Then came the rise of the internet and mapping and everything happened. And after 2005, 2010, deep learning and AI, it came into existence. So that is how no this analyzing the data with the data, how to go with no like all the calculations and know all the analysis. So that's how no it happened. So it is predicted that no like any job, any career which is no like which has the concept of this data analysis, whether it's business data analysis or no like the any data no for that matter. So the data analysis or the no like the data science no, so that is be the future of the world. That is going to be the no the most demanded career no for youngsters. So that is what it has been predicted. So it all started with LinkedIn. So how this big data concept no like came. Uh, know how these Facebook and Twitter and everything has started. So everyone know they started with a very limited number of no like subscribers or no like customers in the beginning. So once this websites or no this social media, it became a no like favorite among the young generations and youngsters, and it became a huge hit. So the number of users, no, uh, it has become no like more. It was no like growing day by day. Number of users for these social media platforms, they were no like expanding day by day because no like whenever a person, if for example take me, so if I find a particular social site, no, very useful for me or very no interesting for me, obviously I will suggest it to my friends and no like dear ones, right? So that's how no the expansion of this social media platforms no happen. Let it be WhatsApp or let it be no like initially there was something called Orkut. I don't know how many of you remember. So Orkut was a social media platform, no, to get connected with your near and dear ones, and even no like people you don't know. Okay, anyone can connect with you. That was before Facebook or Orkut. Okay, then came no Facebook and no like people known to you and people known to those persons who know you. So in that way, no, the network no it expanded, and then LinkedIn came and everything came, WhatsApp and all the social media platforms like Twitter, like Meta, whatever. No, like it is no like now. Okay, so imagine no like if there are 100 users or no like 1,000 users, okay, let it be no like 1 lakh users. It is easy no for any computational purpose, all the information about these users. So whenever I use any no like a platform, I have to give my information, right? My name or no like the other details of mine, no, I have to feed it to the system, feed it to the application or whatever. So imagine no 1 lakh users of the same social media platform. So all their information, including their name, age, and no like other information, no, The system has to store. It has to store. It has to know do some calculations and know like it has to predict something. It has to know like analyze know like what has happened in the past. It has to know like give ideas about know like it has to know like assume know what will happen in the future. So how much know the social media website is can know like it's expecting know like in the how many more users it's expecting in the nearby future. So everything it has to do. So 1 lakh customers, 1 lakh users, that's fine for any normal system. But imagine, no, if it is no like more than 1 million or no more than 10 million users or more than no 100 million users, how can a normal system do it? Okay. So you need bigger thing, no, to store all the information about no these 100 million more users. Yeah. And not only that, you have to store, you have to know you have to calculate, you have to know interconnect with everything. So this is no like something very massive. You can't even think about it. It's like no it's like an ocean or it's like like the cosmos. So something so massive and it's expanding. Actually, no, it's growing day by day. It's growing. You can't say no like okay, so maximum only these many customers can be in the Twitter. You can't say that. Or only these many customers no are allowed in Facebook. You can't say that because no number of users no they are growing. So enormous data no it has to be handled, and that's where no big data no came into scene. So it does the statistics using the computer science and it works on the data. Okay. So analytics, it is an encompassing and multi-dimensional field that uses mathematics, statistics, and predictive modeling and machine learning techniques to find meaningful patterns and knowledge in the recorded data. So that's how no like it quickly makes a calculation and give us a result within very short span of time. So, what does a business analyst do? Okay, all they have to do is input the data. So give the prompts to the data, give the prompt to the that technique or technology, whatever it is. No, so give the prompt. So the correct prompt so that they can get the correct result, whatever they have in mind, whatever result no they want to know like have the system to give it to them. So accordingly they have to give the prompt or no like give the code so that no the system does all the mathematical, statistical, machine learning calculations. It processes the data whichever is feeded by the no by any human no to the system, whichever is no like provided already provided. So only based on those feeded data it will do the calculation. Though it simulates like a human, it is not actually a human. Okay, so um what do you say, it can only simulate like human, it can only think like human, but it cannot show no include all the emotional part like human. So no mission is always a mission, it cannot be a human at all. So whatever data is no like feeded into the system, only based on that data it do all those calculations and give you the result. So that is what no business analysts do. So a business analyst role is to collect all the information and no feed it into the system. So the information becomes data. So store the data in the big data platform or whatever it is, no, in the technology, whatever it is. So store it and retrieve the information whenever, wherever, no, it's necessary, and make the system, no, like give the prompt to the system to calculate it and do some, no, statistical and mathematical calculations, and no, like ask the desired return result. So, for example, a business analyst know he or she can know calculate. I mean, ask the system to know like calculate what are the types of customers who is going to buy a certain product. If the company is know like dealing with multiple products, so know they can specifically ask. So how the system calculates and give it to you? It is completely based on the customer feedback
لو
and
سمحتوا معلش
information.
حصة.
So guys, make sure you are muted. Okay. So it is based on the customer feedback, which is has been no which is the information, and that information is fed to the system, and that information becomes data. So based on the data, so at least a part of customers would have no given feedback at that no I would like to buy this product no, and the question may be when are you planning to buy it? They may say no maybe by next year or after my, by next month or something. So based on these feedback, the system will do all the calculations, statistical, mathematical calculations, and it can give the approximate or an accurate number. Okay, so types of customers who are going to buy a certain product. And they can, the business analyst can ask the system to compute this, forecast the sales which is going to happen in the future, or what is the most bought product, the maximum bought product, and they can generate the inventory report. So anything, any kind of information can be retrieved from this big data. Okay, this capable. Okay, so what are the scope? Where does it work out? Areas of analytics. So where and all you can use it. What and all you can do with it. You can forecasting simulation can be done. Okay, so it can simulate the forecasting and everything, give you the exact or approximate number of units the organization can sell in the upcoming season. And test analytics can be done. Data mining can be done. You can get any information about any customer, okay, wherever they are. So if their information is available in the system, you can easily do the data mining, and it searches all over the internet. It doesn't just deal with the data which you provide. It searches all over the internet, okay, and gives you the maximum information. So data mining, yeah, there's a scope, and statistical part and optimization. There is you get the optimum results out of the data you have stored, and visualization. It can give you in a visualized format. If the say you're asking it the calculation and it gives you result as say sigma 62.32 square. We don't understand this, right? So this is the result. No, it calculates something and this is the result. We don't understand what it is actually trying to say. But if it gives in a picturized format, if it gives us a visual representation, like in bar diagrams or pie charts, we can easily understand. So visualization, so that is also possible. So that it can, human can easily understand, easily they can predict what is going to happen or what has already happened. So this is how it goes. First, identify and formulate the problem. If you want to go for some analytics, first you should have a purpose. Why you're doing the analytics? If there is no purpose, there is there is no use in doing some analytics. So there should be something. Some event should have occurred. Something should have happened. Okay. So some problem would have occurred, or that problem is there. You're going to find a solution to that problem. So for any reason, first identify and formulate the problem, then prepare the data and do some data exploration, because few data may be, duplicated, few data may be, irrelevant, and few data may not be, complete. So you have to go through all the data before using the data for exploration. So data preparation and data exploration, and then transform and select the required data. Only select those data on which you're going to do the calculations. Then build a model. Select the correct model, whether you want to go for qualitative or quantitative, whatever it is, right? So there will be many models available while you're going for analysis part. So build a model, then validate the model, and deploy the model, use the model, and evaluate and monitor the result. So this is the steps in going with data analytics. So there are various roles who are these persons deal with business analytics. So business analyst will do data exploration, data visualization, and report creation. But on the first basis, it's a business manager. So this person is a domain expert. So they make decisions and evaluates the process and ROI. Then data miner or statistician, what this person does is exploratory analysis, descriptive segmentation, predictive modeling, and other things. Then finally, the IT or systems manager, this person does model validation, model deployment, model monitoring, and data preparation. So there is a lot of scope, like for younger generation and students, when they take data science, as their subject domain. So that is going to be the future. Okay. Okay. So big data statistics, this is what they have no like assumed. This PPT no like prepared last year. So that's why no like I have no like made this. So by 2025, it was assumed that there will be around 70 trillion gigabytes of data. That is 70 zettabytes. So in 2012, only 0.5 of all data was analyzed. So imagine the difference, okay, from zero point 0.5 to 70 trillion gigabytes. So that is a large amount, right? That is a large volume. So 2.5 quintillion bytes data are generated each day by the internet users because we live on internet. We can't imagine a future or a present no without internet. For everything we need internet. Okay, so all our information, no, our personal information, our banking information, our no educational information, our work information, everything about us. Sometimes no, even our medical information, no, everything is available. So everything, no, like we do it through internet. No, without internet we can't survive, right? So that's why no, like to manage this much data, no, so you need the big data. So in 2019 there were 2.3 billion active Facebook users and they generated lot of data. So what is big data and why does it matter? So should we really have big data? Can it be no like more simplified? So it is a term applied to a data set that exceeds the processing capacity of conventional database systems. So, or it doesn't fit the structural requirements of traditional database architecture. So, I don't know, like whether you guys know, like heard of it. Initially, there was no like before Excel and all came, no, there was a software called database. It was just called database. It was no like abbreviated. It was no like called as DB, just a DB database. Okay. So when DOS was the operating system at those times, no, like I think in the early 2000s, no, like even before that in 1995 or 96 when I was doing the schooling. Okay, so that was no like that is how no initially it all started. So DB was the database software, no, like uh, we were introduced to, no, when we were in school education, we were introduced to, and then came Microsoft Excel. So no, like with more calculations part and no more features and all, no, like for us it was like no from what do you say, no, from a black and white film, no, like we are seeing a color film. So for us, no, it was like that. Then Excel, no, like became very popular. So they added more and more features to Excel. And on the other hand, no, to deal with the, no, like the big data, there was other database systems like Oracle and connectivity systems like SQL and many things were happening on the other side. So that's how no like when there was a certain point no you have to link this uh the you have to link this data system to know like another connectivity this thing connectivity technology so that wherever you're in the world you can no retrieve the data. When you're using Excel, if I am using Excel in my system, no one can access my Excel sheet, right? Because no like I haven't shared with anyone, so only no like I can no use it in my system. But the organizations no like since they were no like going globally, dealing with global operations and dealing with no like multiple users and no like multiple employees, they had to share information with others as well. Okay, so for that reason no they were looking for some connectivity. So that's how no these software engineers, computer engineers, no, they came with no like the CRM, ERP systems and all. So there was a data. So whichever data you feed into the system, all the other players in the organization, whether it be the vendors or it could be the third party people who supply services to the organization, or it could be the top management, or it could be like any other departmental managers, or it could be the normal employees. Anywhere, whoever can has the access to the server, has access to the CRM or ERP, whatever. So they can retrieve the data. So that is how it all started. And then the data it like when it grew like more and more, there was a necessity for big data. So normal data comes from your traditional relational database system. Okay, so this is how no it was done. Sorry, give me a second. Okay. Okay, I'm sorry. So normal data comes from your traditional relation database system. That is which less data, okay? And big data comes from different data sources. So data are usually in petabytes or terabytes, okay? Now you can easily like access everything together or move your file from like one application to another application. You can convert your PPT into like say what do you say, PDF file, then again convert the JPG into like another file, and no again like convert the PDF file back into like JPG file. You cannot transfer your information anywhere here. So that is how it worked out. So what are the characteristics of big data? So there are important three V's: volume, velocity, and variety. So volume is like big data starts as low as 1 terabyte. 1 terabyte itself, it's the something which is so big, and it has no upper limit at all. So that is the main feature of the big data. There is no upper limit. It can keep on like taking on more data. It can store more data, and it can like calculate more data. So volume. Second one is velocity. So big data enters an average system at velocity ranging between 30 kilobytes KB per second to as much as 30 gigabytes GB per second. The third one is the variety. That is, big data is composed of unstructured, semi-structured, and structured data set. How much, like whatever the data set is, or how much ever the data set is, that doesn't mind. That doesn't matter. So whether it is an unstructured data or a semi-structured data or a structured data, you can like deal with variety of data. The only thing you have to see to it before taking the data for calculation, for analysis is you have to do a data exploration. Without doing a data exploration, you cannot like go with the computation, because few data may be needed, may not be needed, may be duplicated, may be missed out. So you have to see all to that. So with the use of AI or whatever, find where and all the data was like duplicated, find where and all the data is missing, or find wherever the particular data is not needed for the computation. Okay, so do the data exploration and then like go for computation. So this is an example of like this Netflix. So approximately 97.2% of organizations are investing in big data and AI. So only by utilizing big data, Netflix managed to save 1 billion per year on customer retention. Because like it was Netflix. There was the first company who came up with the subscription part. Okay, so came up with the like this channel subscription part, because they know what the customer, they have to like cater to the customer's demand, and each customer is like different. Each one will be having like different demands. So they understood, Netflix understood this. So they didn't go with like same kind of like service or same kind of products. They didn't go with it. So they understood the importance of customization of the products or service given to their customers. So they used big data, and it uses AI concept as well. And each customer is like suggested movies or songs or like series, whatever it is. Each customer subscription is like the big data will suggest films or whatever it is according to the customer's taste. How it comes to know? Because the customers used to watch few channels or few movies, right? So based on the number of movies the customer, each customer, individual customer has watched, Netflix would like suggest some best movies for the customers. For example, if I am watching say sci-fi thrillers, okay, sci-fi thrillers I'm watching, and I'm mostly interested in like series and not in films. Okay, so I'm now like most interested in sci-fi series. So if I'm watching one or two series, no, like obviously next time when I switch on Netflix, it will suggest me more sci-fi series. It will suggest me more sci-fi series. No, so that no, it retains me. It retains a customer like me. Okay, so that's how it functions. So this is no like the Facebook through big data, no like with the help of big data, Facebook has no like come with this face recognition, this technology or software or whatever it is. So it was possible only through big data and Uber's data-driven rating system. Okay, so that is also no like another popular framework. So yes, we are done with our discussion. So if you have anything to ask or no like anything to suggest, if you're in the big data field or if you're no like a part of that technology or whatever it is, so you can give your comments or you can give your suggestions or you can give an insights about what is happening in that industry because I'm not a tech savvy person. I'm not a no like I'm not into technology or I'm not a tech savvy person. So whatever I have heard, I have researched, no like I have given here. So there are more to go. This doesn't no like mean no like this is all about big data. There are no like still more to learn about big data. Like we have to know what is Power BI and we have to know like other business, other data analytics, no, as well. So we will be having two, three more sessions. And yes, so your suggestions and your doubts are welcome here. I'll be here for another 2 to 3 minutes.
Thank you, ma'am.
Yeah, you're welcome. Okay, so in this case, will meet in another session. Thank you for participating and have a great weekend. Thank you.
Thank you.
Yeah.